Okay. Now, when I do this problem, I would rewrite it this way. It's 3 times the sine of x to the 4th minus the cosine of x to the 5th power. There's some question about that when I looked at your quizzes of people getting that confused. You can't even put this into your graphing calculator unless you rewrite it the way I just did. Okay, so you ready? So first thing I'm going to do is the outside function. That's this one here. It's the 5th power. So do 5 times 3, which is 15, times whatever's in there to the what power? 4th. Are you okay if I just... I think, well, nah, no, I saw the quiz. No, some people try to make this the cosine. No, it stays the same. Then we do times the derivative of the inside function. The next inside function is this one. So it's times what? Cosine of whatever's in there, that's x to the 4th, minus the cosine of x, times, and I ran out of space, times the derivative of this piece, which is 4x cubed minus, oh no, it's not minus, it's plus the sine of x. Do I need the parentheses around that? Absolutely. There it is. So first I did the outside, the way outside, which is the 5th. So it's 5 times the 3, which gives you the 15. And then whatever's in there stays the same. So it's still the sine of x to the 4th minus cosine of x. Then we do the derivative of the next function, which is the sine. So it's the cosine of whatever was in there. Then the last thing, times the derivative of this, which is that, and then times the derivative of x. But that's just 1. Okay? Because we have too much to do. Okay, so let's look at what is the derivative. This is important. This is the chain rule that we think we have, but we don't. I want the derivative of x squared with respect to x. I'm going to do this a variety of different ways, and hopefully one will catch on. This is going to take a couple days. This is not going to be immediate. I'm just doing this problem. I'm just preparing you to do the implicit differentiation. Any place. Turn your paper over, put it in the back. I don't care. What's the derivative of x squared with respect to x? It's 2x. Chain rule. Times the derivative of the inside function with respect to x. But what is that? That's 1. So this is 2x. You're saying, well, what's the big deal? What about the derivative of y squared? I'm going to write it this way. But with respect to x. And with respect to is critical because it's the chain rule. If I change x a little bit, then my function, my y value changes. And if I change the y value, the square of the y value changes. So I have to chain it. And we had some problems in the homework kind of like this. So I do the derivative of the outside function, which is, okay, Noah, 2 times y to the what power? First, times the derivative of the function inside there with respect to x. So it's times the derivative of y with respect to x. That is not 1. Why is this one 1? Because these are what? The same things. Let me try it a different way. Let's say y is equal to f of x, because it is, right? So in place of, and this is where it looks like the homework, and I remember seeing that in the book someplace, I'm going to find the derivative of y squared with respect to x, but in place of y, I'm going to put in f of x. Right? We did that in the homework, if we did the homework. Someplace. What is the derivative of this? What's the outer function? It's composite. 2 times whatever's in there to the first power. Times, then you have to do the derivative of the inside function. So it's d f of x dx, or f prime of x. Some of you may prefer to do that, that's fine. Now, but what is f of x? f of x is simply my y value, so that's 2y. And what's f of x here? dy dx. So when you do the derivative of y squared and you say it's 2y, you're doing the derivative of y squared, you're saying it with respect to y, because it's 2y times the derivative of the, always times the derivative of the inside function with respect to whatever that was. And that's just 2y. So what if I have, one more try here, what if I have the derivative with respect to time of y squared? Then we do the derivative of the outside function, which is the squaring. So it's 2 times y to the first power times the derivative of the inside, but with respect to that letter that's in the denominator. So what's this going to be? dy dy dt. That matters. And that actually, if you're talking about the change in the y as time goes on, is the velocity in the y direction from physics. So what with respect to is important. Why do I want dy dx? What is that? It's the slope of what? Of the tangent line. That's why I want it. I could do the derivative of y with respect to star, with respect to anything I want. Okay, Jack? Okay, now we're going to start doing the hard stuff. I may have to come back to this again because some of you are going to not connect it yet. That's okay. Well, this is a tough lesson. This is probably one of the toughest ones. Okay, so I want to find the derivative of this function. And it is a function. Do you know what it looks like? 1 over x looks like it's a hyperbola that's rotated. Looks like that. Not that I need to know that, because I don't really need to know that to do the problem. So I would like to find the derivative of x times y equals 1. I could solve explicitly for y. Do you agree that if I have x times y equals 1, and I divide by x, I get y equals 1 over x? Okay, that's what we mean by explicit. When I give you directions and I say do this, it's explicit. When I say, when I don't say justify your response, because it's always implied, you must always justify your response. That's an implication. You see the difference? It's not, may not be explicitly stated, but always justify. Okay? And sometimes I'm not good at that, and I forget to remind you. We always justify it. So I'm going to do this problem 2 ways. I'm going to do this way, y equals 1 over x, and x times y equals 1. Okay. So you guys know how to do the derivative of y equals 1 over x? Well, I would make that y equals x to the negative 1. Now, has anybody memorized that derivative besides me and the BC Calc kids? We know what that is. Well, you will know what it is. I don't want to use the quotient rule. That's too hard. Y prime is equal to minus 1 times x to the negative 2, or I prefer dy dx, actually. dy dx equals negative 1 over x squared. I prefer dy dx because it tells me what that denominator is. It tells me it's x. I could be doing dy dt. There's nothing that says that about y prime. Okay, are we okay with this one? This is just the derivative of x to the negative 1. Now, the operator that tells me to take the derivative is this d dx. Take the derivative with respect to x. Now, last class I said, well, what's an operator? Okay, Noah? An operator would be like if you saw 2 plus 3, you would know that that means to do what? Add. Okay? If you see 3 squared, the operator is the squaring function. Casey? If you see the square root of 25, the operator is the square root function. Those are called operators. So this one, this d dx, is telling me, that I want to find the derivative of both sides. That's all. It's an operator. Yes. d dx says find the derivative with respect to x. dy dx means the derivative of y with respect to x. This says find the derivative that it says the derivative is. We say dy dx because that's easy to say. No, what? Say that again. This is used as an operator, and this is meaning the derivative. That means derivative. The answers are the same, but I could be doing d dt, and then it'd be dy dt. The d over dx is called an operator. It's like the plus sign. And when I see it with 2 and 3, I know to add them. So when I see this little d dx means let's find the derivative of that, or differentiate. Fancy word. No, it's like a plus sign, or minus sign, or division signs, an operation. Okay? And we'll find the inverse of that operation. What's the opposite of squaring? Square rooting. So there's got to be an opposite to a derivative. It's called an antiderivative, or integral, for those of you who know what that is. Okay. So I'm going to rewrite this so it's bigger, and I'm going to exaggerate the dot there, because what does the dot say? Multiply. Okay, Noah? So I want to find the derivative of y with respect to x. So the way to do that is to take the derivative of both sides. Now, this is implicit. I have not solved for y. Some of you are saying, well, why don't you just solve for y like you did and just do it that way? Because sometimes I can't. And sometimes it's easier to do it this way. You will have a y in your answer. So the operator is this d dx. It says, I'm going to find the derivative of the left side, and I'm going to find the derivative of the right side. And I put a big dot there. I don't know if it's big enough for you to realize what rule do I have to use. Not quotient, product. So it's x times the derivative of this one. Well, it's the derivative of y with respect to x. Hang on. Let's not simplify yet. Let's just write it. This is my plan. Okay? Plus this one times the derivative of the first one, the derivative of x with respect to x. And then we'll do the easy one. What's the derivative of a constant? What's the slope of a horizontal line? It's 0. I know, and that will mess you up when we take the quiz on this. Okay, I'm going to stop right there. Is that okay? Okay, Noah? It's the first one times the derivative of y with respect to x, plus, then I have to keep the y here the same, and it's the derivative of x with respect to x. Now let's simplify that, because there's some obvious things here. Now, if you prefer y prime, be my guest. I don't like it because I forget the primes. I mean, I miss them. My eyes aren't that good. So it's x times the derivative of y with respect to x, which is what I want to find, by the way, plus y times what? 1. Now, no matter how I take a derivative, I got to get the same answer. So it's x times dy dx. I want to solve for dy dx. So what do I have to do to solve? Subtract what? Then I'm going to show you I get the same answer. You may not think it's the same answer until I do a little bit of algebra. So x times dy dx, or y prime, whichever you prefer, is equal to minus y. And then we do what? Divide by x. The algebra is going to get us in trouble once we catch on with the chain rule. I don't expect mastery. We're going to spend 3 days on this. And it's minus y divided by x. And some of you are saying, that's not the same thing as this. Well, what's y equal to? Y is equal to 1 over x, right? So we'll go ahead and substitute it in here. Now, for those of you who don't see that, that's still negative 1 over x squared. Let's do the work. I'm going to multiply by x over x because I'm multiplying by 1. Remember how I did that with fractions? I always do it that way because then I never have to deal with fractions. So it's equal to negative, let's see, the numerator becomes negative 1 and the denominator becomes x squared.
Too many variables.
Oh, but think of dy dx not as a variable but as a derivative.
Can you explain that?
Yeah. this part right here, this is x over x, which is 1. Because that's a complex fraction. I'm just trying to show you it's the same as this. You missed the first unit. That's where I showed you how to do the complex fractions. I don't want a fraction in a fraction. I want to get rid of that. I'm just trying to show you that they're the same as this. That's all. Okay. Some of you are still saying, why are you doing all that work? Because it's just be easier just to solve for y. No, it actually isn't. Now, we're going to turn the page, and we're not going to do the, well, we're going to look at that problem first. Can you, in example 1, which is the hardest one on here, we're not going to do an x, we'll do an easier one. And I'm hoping the homework starts off that way as well. Can you solve that equation for y? I got a y squared times the sine of y minus 4xy. Can you solve for y? No. It can't even be done. So the only way to do this is just to take the derivative, we say implicitly, okay, Alex? We say implicitly, we're going to take the derivative as written. But that one's kind of complicated. Let's do some easier ones first. So let's skip down here. This is a hyperbola. No, hyperbola. It looks like this. I'm just thinking, do I have this the right way? Is that a function? No. You haven't done, these are called conic sections, because if you take a cone like this, it's a full cone, actually it looks like this, and if you slice through it with a plane, I mean, my picture's not the greatest, I get this shape. It's called a hyperbola. They actually build buildings sometimes. There's a building in Minneapolis that has the shape of a parabola built into it. Structurally, I don't know if that works. It's on Washington Avenue. You've seen it. They're called conic sections. If I put a plane through there, I'm not very good at drawing that. You should see this kind of curve. And you can look it up online. But it doesn't matter to do the problem. Next week. Thanksgiving's next week. No, it's next week. We have 5 Thursdays. It's always the 4th Thursday. There's 5 Thursdays in this month this year. It's next week. It's the 22nd. Then we only have 3 days next week. Okay. Okay, you ready? Could I solve that for y? Yeah. Now, okay, guys. So we can get through this today. It's distracting to me and others. Okay, Casey, can you solve that for y? Do you want to solve that for y? We can, and if you want me to, we will. It's easier just to take the derivative as it is, implicitly. It's just so much easier. So I'm going to rewrite it here. X squared minus y squared equals 1. And I'm going to use my derivative operator and take the derivative with respect to anything I want. In this case, I'm trying to find dy dx, so I want with respect to x. I'm going to do this with respect to x. You may distribute. Some of you might memorize it, but I'm trying to find a derivative because I'm going to change that denominator on you. So we got to get it. Well, what's the derivative of x squared? Now I'm going to write it all out. So at least it doesn't look too magical. Okay. So the derivative of this is the derivative of the outside, which is 2x, times the derivative of the inside with respect to x. Some of you are saying, why don't you just write 1? Because it is. Because what happens to the next one, Jack? What's the derivative? Whoops, that's a minus. Minus. And what's the derivative of y squared, or something squared? It's 2y times the derivative of what's in there with respect to, not y, x. And that doesn't go away. And if it did, I wouldn't have a dy dx to solve for. So that'd be another issue. Okay, and what's the derivative of 1? 0. Now I chose the y equals 1 over x first because you could see it both ways. And we could do this both ways if you want. So this ends up being 2x because what's dx dx? 1. You can think of it as derivative, or you can just think of dx as canceling. And then it's minus 2y. If you want to make that y prime, I can. I prefer not to. And then we're going to solve for dy dx. So we are going to subtract 2x. And so minus 2y, be careful with your signs, I wasn't, equals minus 2x. This is algebra now. Divide by negative 2y. Now what they're going to probably do on the exam, if it's free response, is give you a function, and this is not a function, it's a hyperbola, give you an equation and say, show that dy dx, and we'll give you one to do that, but dy dx is equal to x over y. Now, they have not done a free response on this one for a while. I don't think we did it last year. So it might be time. But I like it because I like it better there than the multiple choice because it says show that. If you understand the first part here and you have problems with the algebra, I think you can fudge your way through it and get your points. You'll see. I'll give you something to practice with. Okay, that's it. Yes. They say not to. I think it's questionable. If you have a bunch of work, if you circle the wrong thing, then you're going to get it wrong. If you put the right answer and you don't circle anything, you might get it right. Yes, you could do that. But you don't have to. You could. Sophie solved this equation for y and put it back in there. And you could do this. If you solve for y, you get y equal to the square root of, you get plus or minus. So 1 minus, x squared minus 1. And then you have to do the chain rule, and it's kind of ugly. You will see where it pays off to do it this way. Right now, you're just beginning. Are we ready to try the next one? It's getting a little tougher. Example 3. I don't want to go to the... We'll do that last, because it's tough. Okay, so I have x squared. No, I have x times y squared. I'm going to exaggerate that. Equals x minus 8. Times, because that was missed by many on Friday. Times, what rule? Product rule. And I was harsh. I'm sorry, but I was. So it's the derivative with respect to x of the product. And then now you distribute this. You can distribute over a sum. You just can't distribute over a product, unfortunately. I wish you could. Well, life would be so much easier, wouldn't it? Except it's not right. Okay, you ready? I just like to put my operator in. Okay, ready? So we're going to start. I just always start with the first one times the derivative of the second. You could reverse it. It doesn't matter. So it's x times the derivative of y squared. What's the derivative of y squared? 2y. That's the derivative y squared with respect to y. Times, and you have to do the inside function, the derivative of y with respect to x. That with respect to is critical. Oops. That's the first part of the product rule. Plus, then we do the y squared times the derivative of the x. And I'm going to write it. Some of you will get it and say it's just times 1. You're right. It's the derivative of this function with respect to x. Why is it 1? Because this is 1 for two different reasons. Dx over dx is clearly 1, algebraically, but it's also the slope of y equals x, which is 1. Now that's the left side. Equals. And what's the derivative of x with respect to x? That's 1 minus 0. This is so bad? No, but that's because you guys pay attention. The other class doesn't. Okay, so I get 2xy times dy dx plus y squared equals 1. I just multiplied that out. It's not distributive property. It's associative. Distributive property of multiplication over addition. There's no addition there. And then I want to solve for dy dx. So what do we do next? Minus. Now you could also solve for y here, but it wouldn't be pretty. I have to use the quadratic formula, I think. Oh, no, maybe not. But it's still not nice. So minus y squared, and so I'm going to get 2xy. Is that okay, Sophie? dy dx equals 1 minus y squared, and then do what? Divide by 2xy. This is algebra. So they might say, give you a problem like that and show it looks like this. It'll be a little probably harder than that. You got to tell me if you're not getting it, though. Do you see why it's the big thing here? It's the chain rule. The big thing is knowing what to do with the derivative of y squared if we change x. If we change x, then y changes. And if y changes, then y squared changes. It's the chain rule. Yeah. Wait, why did I what? I did right here. It's right there. It's x times 2y dy dx, and then I just commuted those. Because it's x times the derivative of the y squared plus y squared times the derivative of the x. Product rule. Do you see that? I'm not sure what your question is.
No, my question is that, like, so on the second line, you know, you took the, so like, you multiply the x to the dy dx.
It's not distributive because it's not, it would have to be this. 2y plus dy dx. Distributive property of multiplication over addition. There's no addition. Which is why it should always be taught with the multiplication and addition. Because not everything distributes. Derivatives distribute over sums, which is kind of nice, but not products. Yeah. No. I'm keeping this as a single thing. Y prime. First I subtract the y squared, and then I divide. This still stays this. So I'm sorry, I should have finished this. dy dx equals this. Oh, yeah. Now, I know that when you get home, you can always get it here when I'm here. You go home and you open the book and you say, I don't know what to do. Try it. Plus, I'm here in the morning. Well, this morning I was a little late because of the snow. I left late. I left my iPad at home. That one's a little easier than the other one. Let's try this one. It's not a lot easier. Oh, we'll come back. We'll do that one last. It's the toughest one. Oh, we're okay. Oh, that's not what I wanted to hear. Okay, ready? Now, can you solve this equation for y? How? The y is in my angle. I can't solve for y. You have no choice but to take this implicitly. And I always want to do it implicitly anyway. It's usually easier. Okay, ready? I can't. So I'm just going to find the derivative of y with respect to x by taking the derivative of everything here. So I can't solve for y. But I can distribute the derivative operator over a sum. Okay, what rule do I have to use for the first one? Product rule. So it's x times the derivative of the second one. This is what this means. dy over dx is the derivative of y with respect to x. That's dy dx. That's what I want to find. If you don't get a dy dx in there, you're in trouble because you can't solve for it. Plus, then it's y times the derivative of x. I'm going to write it. That's the very first one. Because it's the derivative of this with respect to x. If this were a z, it would be times dx dz with respect to x. What is that going to give me? 1. This is not going to go away. Maybe Jack has an idea here. Plus, now we have a whole bunch of stuff going on. First, you have to do the sign. What's the derivative of the sign? Cosine of whatever's in there. Remember? Times. Now the derivative of x times y. We just did that, didn't we? Well, we're going to do it again. We'll say it again, because the more you hear it, the better it is. Now I have to do the derivative of this. So it's x. The first one times the derivative of the second. Well, I don't know what to do with dy dx. That's just what it is, isn't it? Yeah, that's right. Plus, but I'm just reinforcing. Then it's the second one times the derivative of x with respect to x. But we know what that is. That's 1. And the derivative of my constant is 0. Okay, this is the hard part. I want to find dy dx. I want to solve for dy dx. And to do that, that's the algebra. If we get this, then we got the chain. You now have the chain rule, if you get that line right there. So we're going to solve for dy dx. To do that, I'm going to clean it up. It's messy looking. Okay, so that's x times dy dx. You can make it y prime if you like, plus y. Because that's just 1, right? Is that right? Jack and Jake, you got it? The derivative of x with respect to x is 1. Plus, and I'm going to distribute this in a moment. I just want to clean up that green stuff as well. Sounds terrible. dx plus y equals 0. And the hard part here is going to be the algebra. I have to distribute this. I have to do that to solve for dy dx. So it's x dy dx plus y plus, now I'm going to multiply these together. It's x times the cosine of xy times dy dx. And then I'm going to distribute the cosine of xy to the y. So it's plus y times the cosine of xy equals 0. If it asks you to solve for dy dx, no. But let's say this is what you have, and they're going to, if it's free response, they'll say, show that it's this. Yes, but you know what the answer is supposed to be. Can you, if you know what the answer is going to be, can you manipulate it to get there? I think so. Okay, I want dy dx by itself. So and unfortunately on the exam, you can't bring in highlighters. I really don't know why. But these guys I want on the left side of the equation, and I want to get rid of everything else with them. Added. We always undo adding next, right? Can we do this quickly? You're not going to make me show subtracting y from both sides, are you? So it's x dy dx plus x cosine of xy dy dx. I want to keep the yellow pieces right on the left side, and I want everything else over there. Yes? Yeah. Yep. Further? I want dy dx's by themselves over here. So to do that, then I'm going to subtract this y right here. I'm going to subtract this one. We're almost done. And then I'm going to factor dy dx. because I can't solve. I'm going to factor this out. And of course, I ran out of space. And since we're not going to do this little problem here, well, maybe we will tomorrow, but today we're not. So this is what? Factor out the dy dx, and I'm left with x plus x cosine of xy. Right? Got that? That equals minus y. Why did I factor it? Because I need to solve for it. And we had some problems with that. Oh, maybe we didn't do the inverses. I don't remember. Well, I don't think we did. And now we divide by that. Well, it's not that bad. You don't like the letters. Who here is interested in engineering? Lots of letters. Question. The question is, where did I get this right-hand side? This piece right here. I subtracted this one and this one because they didn't have any dy dx's in them. Now we're going to divide by this. And now normally we probably can't do any more, but if you look at this one, you'll realize we can. That goes. So I get dy dx. Can we go ahead? This is interesting. Can we go ahead and factor something out of there? No. How about the y's? A negative y. And I'm left with 1 plus the cos. I'm undistributing when I factor xy. It's probably not going to be factorable in the exam. And now I'm factoring the y's out of there. What should I factor out of this one? X. Because some of you seen what's going to happen? Because I can reduce this. It's probably not going to be something reducible. And what happens to the 1 plus the cosine xy? I mean, it's hard to write a problem where it will reduce. Very hard. And there it is. This is going to be okay, by the way. Well, that's just going one step further. It's not that big a deal. Just algebra. Just algebra. Okay, you ready to tackle the tough one now? No, we're doing it tomorrow. Well, things got all messed up today with the veterans thing. Yeah. Okay, let's try the last one and be done. And tomorrow we will deal with your quizzes, correcting them, and also going over homework questions. Yes. But I think in the future I might say you have to turn your homework in when you take the quiz. But yeah, I don't remember what you got. I think you did okay, though. I think you did okay. And what was the score? Yeah, it does. Yes, it does. It's in the comments. No, because that. Oh, okay. I don't know. I think I have 14 or 15 out of 22. 59%. Let me tell you how many you got right. Like 15 out of 22. No, we changed that for the formative stuff because people weren't doing the homework. Okay, you ready? Should we try this one? Remember, it's formative, and we're going to throw the lowest one out anyway. You're going to make corrections. Formative. Okay, you guys ready? I know. We have 10, actually. We can do this. What rule do we have to have here? Product. Okay, I'll tell you right now, solving for dy dx is not easy, so we're not going to do that. Now, usually what they're going to do if it's a really ugly thing, like this is going to be pretty ugly, they'll tell you x is 0 and y is 0 or something like that, and you'll just evaluate it. It'll be a lot easier. If they give you a point where you evaluate it, then you want to just find the derivative, evaluate, and then solve for dy dx. Okay, so can I pull that through that -4, the d dx? Yes. We should know how to do x times y now. Okay. Okay, so we're going to take y squared times the derivative of the sine of y. Can we just go ahead and write it? Or do you want me to put out the plan? So it's the derivative with respect to x of the sine of y. Plus, then it's the sine of y times the derivative of y squared with respect to x. I haven't taken the derivative yet. The request was to do the plan. Now I'm going to change colors. That was for this one. Because it's the first one times the derivative of the second plus the second one times the derivative of the first. I haven't done the derivative yet. I got a plan there. Well, we can go ahead and do the derivative of x squared, right? What's that? 2x times the derivative of x with respect to x. If you are ones that can say, I don't need that anymore, then don't. It's fine. Minus 4. We just did this one, though. Remember, it's x times the derivative of the second. You see the product rule? Sorry. See x times y? Product rule. So it's times the derivative of y with respect to x plus the second one times the derivative of the first. Equals what? 0. Okay. The negative 4 is still there. Yes. I haven't done these derivatives. I'm going to get there, but this is the plan. We're going to do that right now. I know, it's hard. So this one was the y squared, the first one, times the derivative of the sine of y. Let's do that. With respect to x. Now, what's the derivative of the sine function? Cosine of what? Y. Times now the derivative of the inside function. Well, that's dy dx. I can't do anything with it. But if I don't get a dy dx, I'm in trouble anyway. Because how can I solve for it? Plus the sine of y. Huh? No, this is y squared times sine of y. We're just doing the first one in red here. Then it's plus the sine of y. What's the derivative of y squared? It's 2y times the derivative of the inside function. dy dx. Now it's good. Plus what? 2x. And then we could distribute the 4. So it's minus 4x dy dx. And then we can distribute the 4 here. It's minus 4y. But what's dx dx? 1. And I'm going to highlight the dy dx's. If you wanted to solve for dy dx, you have to get all of these on one side of the equation and get the other stuff that's not highlighted on the other side. Those are y's. Yeah. Wait, where are you looking at minus 4? This is minus 4y. Don't forget the y was there. Because it was x times y. X times dy dx. Whoops. The highlighter doesn't work very well. Plus y times the derivative of x. I wish the highlighter didn't do that, but it does. And then you could gather all the dy dx's together and factor, and then you would have to get rid of these guys would have to go to the other side.
Figure out dy dx.
And you would factor out dy dx. Do we have time to do that? Oh, we got 2 minutes. Oh, you're not going to want to come back to this tomorrow. Can we do this all at once? dy dx. Factor this out of this one, and this one. And I'm going to be left with y squared cosine y plus 2y sine y Okay, that one's gone, that one's gone. Minus 4x
I got the answer.
equals, and then this is going to go to the other side, so it's 4y minus 2x. It won't be this hard on the exam. And then we divide by this. But this is algebra. Don't worry about all the letters. They are what they are. Also, your grade is continues. So this little one that we just quiz we took isn't that big a deal.
I feel like I should have got at least I got at least a B-.
The second problem, the first page was 9 points. It was 3 points each. The second problem had to do with the product rule. Everybody missed it. You'll throw it out.